everybody, welcome to another video. Hope you're ready to flex those brain muscles. Today we are going to graph some linear equations. So we already found the x and y intercepts of these linear equations, and if you missed that video, it's right up here, you can click that. But why do we care about the x and y intercepts? Well, this is a good technique we can use to graph these. Think about it. If we have the x-intercept and the y-intercept, these are points on our line. The x-intercept is the point where the line intersects the x-axis. The y-intercept is the point where the line intersects the y-axis. And since these are linear equations, they're lines, all we need is 2 points to graph them. So really, if we can find the x-intercept and the y-intercept, we can just draw a line between them, connecting them, and that's our graph, and we're done. So that's why we care so much about the x and y-intercept, because if we find them, then not only do we know the intercepts, but we can also easily graph it. So that being said, since you only need 2 points to graph a line, any 2 points on the line, you can draw a line and graph it. There are many different ways to do this. I'm just going to explain the way I do it and the way I think is easiest. But if you do it a different way, that's okay. And also just note that my line drawing skills are not perfect, right? This is the Cartesian plane I drew. I don't have a ruler or anything like that, so if my lines are a little off, I apologize, but I think you'll be able to get the idea. So let's go ahead and get into some examples. And the way I graph these linear equations changes depending on what form they're given to me in. If they're given to me in slope-intercept form, like this first example will do, then I'd use a certain method versus with standard, I use a different method. So with the slope-intercept form, what do? Well, it's actually pretty cool because we don't have to actually do any algebra in order to graph something that's in slope-intercept form. It's pretty cool. Why is that? Well, slope-intercept, the reason it's called slope-intercept is because m is our slope and b is our y-intercept. So our slope and our intercept and our y-intercept are easy to identify without doing any algebra. And in the case of this, we have a slope of 3 and a y-intercept of -1. So the first thing I always do when I'm given an equation in slope-intercept form is I graph the y-intercept. So since the y-intercept is at -1, that means this line intersects the y-axis at -1 down here. So I'm going to draw my point down there. Now all I need is any other point, and I can connect those 2 points and graph this. So really what you could do is you could just plug in 1 for x or 2 for x or anything like that and just plug that in, solve it, and then draw a line between the two. But what I like to do is just use the slope. I use the slope, and what the slope means, right, in this case our m equals 3, and what that means is that's our change in y over our change in x. And this might not look that familiar. This is more common to see, rise over run. That's more common. So rise over run, which is just the change in y over the change of x. So the rise is going up along the y-axis, and the run is going right across the x-axis, right? Because think about it, up, the y's are getting more positive, we're adding to the y, and to the right, we're adding to the x. So that's why it's rise over run. So this m is 3, which we can write it as 3 over 1. Whenever you have an integer or a whole number like that, it's nice to write it as 3 over 1 because then it's easy to see what's going on. So what we're going to do is we're going to rise 3 and we're going to run 1. So we start from our point, we start from our y-intercept, and we rise 1, 2, 3, and we run 1. So our point is here at 1, 2. That's our point. 1, 2. And if we want to double check this, we can plug 1 in for x, and we get 3 minus 1, which is 2, and we could have done that in the first place. If that's easier for you, then do that, but it gets a little trickier when there's fractions and bigger numbers. I just use this method of looking at the slope and doing rise over run. That's me personally. So now I just draw a line through these 2 points. I'm going to erase this coordinate so I can draw my line. And I'm sorry, I'm really bad at this. I'm really sorry. But I just draw a line between the 2 points. And there we go. That's the line of our linear equation. This is the graph. All right, so we'll do one more example with an equation given to us in slope-intercept form, and then we'll do a couple that are in standard form so we know how to do both. So same idea. First thing I'm gonna do is graph the y-intercept because it just jumps out at us. It's 4, right? That's the cool thing about slope-intercept. So I go to this y-axis and I draw a point at y equals 4. Now what do? Well, I can use this slope, right? My slope, my change of y over change in x, or my rise over run, is -3/5, -3 over 5. So what does this mean? I'm rising 3, I run 5. That's close But we had to be careful with the sign, right? Think about when this was positive. Remember, we went rise, up, run to the right. But now that this is negative, what do? We rise down and we still run to the right. When it's negative, you'll go down and to the right. When it's positive, you go up and to the right, okay? So, negative 3 over 5, I go down 3, 1, 2, 3, and I run 5, 1, 2, 3, 4, 5. So I'm over here at this point, and this point is what? 5, 1, and I can double check this by plugging in 5 to x. When I plug in 5 for x, the 5's cancel, and I get negative 3 plus 4, which is positive 1. So this checks out. And now I just draw a line between my 2 points. So let's see if I can do this. So it's going to come down here. And there we go. It's about as pretty as it's going to get from me. So yeah, this is our graph of our linear equation. And let's just note a couple things. Since this slope is negative, we have a line that's decreasing, right? As x increases, y decreases. If we have a slope that's positive, like we did in our last example, as x increases, y increases. It's an increasing line, okay? And one more thing. Now we see why this idea of rise over run helps us, right? Because like we said, we only need 2 points to graph this line. So we could have found the y-intercept, and then what if I just decided to plug in 2? Well, when I plug in 2, I get really ugly numbers. I have to multiply this by 2, then I have to find a common denominator. I get to do all that junk. When instead I can just use this rise over run. So this is why it helps, because sometimes it's not the nicest thing to do to plug in these numbers and work with these fractions and crazy numbers when you can just look at this and do the rise over run and plot the 2 points and draw the line. So let's go ahead and go to standard form. All right, so now we'll go ahead and graph a line in standard form. And there's 2 ways we can do this. The first way is we can find the x and the y-intercepts, graph those, and draw a line between them. The second way is we can do some algebra and rearrange this into slope-intercept form. Convert this from standard form to slope-intercept form, and then use our slope and our intercept to graph it that way. I prefer the first method just to find the x and the y-intercepts, but both methods work. I just think finding the intercepts is less work, it's less tedious. So we'll go and do it that way. So I'll find the x-intercept by setting y equal to 0, and then I'll find the y-intercept by setting x equal to 0. I'll plot those points and I'll draw a line between them. It's that simple, right? Okay, so I'm gonna plug in 0 for y and find the x-intercept, and I have 3x plus 5 times 0 equals 9. 5 times 0 is 0, so now I have 3x equals 9. I divide by 3 both sides to isolate the x. Divide by 3, and I have x equals 3. And this is my x-intercept. So this is where this line intersects the x-axis, is at x equals 3. Boom, I'm going to go and graph that right here. All right, now I'm going to find the y-intercept, so I'm going to set x equal to 0. I'm going to do this over here. So 3 times 0 plus 5y equals 9. 3 times 0 is just 0. That can go. So I have 5y equals 9. Now I just divide both sides by 5, right? To isolate this y. Divide by 5. Divide by 5. The 5's cancel, and I'm left with y equals 9 over 5. Let me rewrite this. Y equals 9 over 5. So it's not always the prettiest numbers. Especially with standard form, it seems like it tends to be less pretty. But that's okay. Y equals 9 over 5, so that's just a little bit less than 2, because 2 is 10 over 5. So I'm going to draw this point, y equals 9 over 5, right under this 2 notch. And depending, I don't know how strict your teacher is, but this is usually acceptable to kind of, when it's fractions like this, to kind of estimate. And sometimes you'll be expected to write the point. Let's go and do that. What point is this? Well, let's see. My x is 0, and my y is 9 over 5. And then here, if I write out this point, this time my y is 0, and my x is 3. So these are the points. Sometimes you're asked to label the points, and that's how you do that. So now I just draw a line, and that's going to be it. Let's see how well I can draw a line. Not terrible. I mean, it's pretty bad, but there we go. You get the idea. Cool. All right, this is our graph for this linear equation. All right, last example. 5x minus 2y equals 6. If you want, you can pause the video, try it yourself, and then press play to check your answer. That's a good idea. So I'm gonna go ahead and graph this. What I'm gonna do is I'm gonna find the x-intercept, the y-intercept, plot those points, and draw a line in between. So I'm gonna start with the x-intercept. So I'll plug in 0 for y. So what do I have here? 5x minus 2 times 0 equals 6. Right, this 2 times 0, that's just 0. So I'm left with 5x equals 6. 5x equals 6. And now I just divide both sides by 5. Divided by 5, divided by 5. I got x equals 6 over 5. That is my x-intercept, right? So I go over to this x-axis. I look for 6 over 5. That's right here. It's a little bit after 1. So I'm going to put it right here. And I'm going to write this out too. Let's see. I'll write it way down here. And this is what? 6 over 5 comma 0. Remember we plugged in 0 for y, and we got 6 over 5 for x. So that's my point there. So then now I'm going to find the y-intercept. So let's see, how do I find the y-intercept? I substitute in 0 for x, right? Substitute in 0 for x to find the y-intercept. So I'm left with 5 times 0 minus 2y equals 6. 5 times 0 is 0. That goes bye-bye. What am I left with? My negative 2y equals 6. Now I just need to isolate the y. I can divide both sides by negative 2. Negative 2, negative 2. These negative 2's cancel. I'm left with y equals 6 over negative 2, which is what? This can be simplified to negative 3, right? 6 over 2 is 3. The negative still just chills out here. So y equals negative 3. So let's see. 1, 2, 3. I'm down here. Okay, cool. This time I have a line where the slope is increasing, right? So I'm going to go ahead and draw. Let's see. Actually, first I'll label this. Since I labeled this one, I'll kind of point and arrow to there. And now I'm going to label this one as well, which is what? Y equals negative 3, x equals 0. So it's 0, negative 3. And I'll draw a little arrow to that one as well. That might get in the way. Okay, I'm going to draw my line and see how it looks. Let me see. Start here. Go down all the way through. Alright, so that point is 0, negative 3. This point is 6 over 5 comma 0. Sorry, it's a little messy, but hopefully you get the idea. And if you converted this to slope-intercept form and graphed it, you would get the same line. You get the same graph. It would work the same way. You just have to do some algebra. You basically solve for y. You'd isolate y. And I actually have a video on that. You can click up here. And then you could use that other technique and just plot the y-intercept, use the rise over run, and do that. So hopefully this video helped. If it did, hit the like button, hit subscribe for more. And if you have questions, please leave them in the comments and I'll answer all your questions. So hopefully this helped. Keep flexing those brain muscles and keep making those brain gains. I'll see you next time.